Given angle 1 and angle 4 are supplementary, we need to prove that A and B are parallel. Now, there's a bunch of ways that you can prove that A and B are parallel, and here they are. You can show that two lines are parallel if corresponding angles are congruent, if alternate interior angles are congruent, if consecutive or same side interior angles are supplementary, means they add up to 180, if two lines are parallel to the same line, if two lines are perpendicular to the same line, or if alternate exterior angles are congruent. So those are the ways that we can prove that A and B are congruent. Let's see what I'm going to do. Whenever I have a two-column proof, I like to make a little bit of a rough draft. So I need to get from 1 to 4. Actually, I have 1 and 4. They're supplementary. So I need to show that A and B are congruent. So maybe I could take 1 and 4 and use that to connect 3 to 2. And once I show that 1 and 2 are congruent, then I have corresponding angles are congruent, therefore A and B are parallel. So that's my goal. Take 1 and 4, get to 2, and show that 1 and 2 are congruent. So a little rough draft over here. 1 plus 4 is 180. From that, I can say that, well, since what am I told? I'm told that C and D are parallel. That means 3 plus 4 is also 180, right? Now, I can look at this and say, like, okay, well, I see 4 in common, but that doesn't really do much for me. I also see that since they're both equal 180, I could say 1 plus 4 equals 3 plus 4, but that doesn't really help me. Not yet. Because if I were to do that, that gives me 1 equals 3. I'm not there yet. And I want to connect 1 and 2. I need to get 2 involved. But you know what? 3 and 2 are the same thing. 3 is 2. So I can now say that 2 plus 4 is 180. So if 1 plus 4 is 180 and 2 plus 4 is 180, then 1 plus 4 equals 2 plus 4. There's a 4 on the left. There's a 4 on the right. They cross each other out. 1 equals 2 gives me exactly what I want to make this proof happen. So that's the order that I'm going to do things. I'm going to start first off with my given. Okay? Angle 1 and angle 4 are supplementary. Abbreviate, you're allowed to. Also, C is parallel to D, and that's going to be my given. Always, 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 always start out with your given. Now, if 1 and 4 are supplementary, that allows me to say that the measure of angle 1 plus the measure of angle 4 equals 180 degrees. Now, I didn't write all the cute little symbols over here because this is my rough draft. I just have to make sure that I write my symbols over here. Now, the reason for that is the definition of supplementary angles. Look, abbreviations again. Use them. Do it. Do it. All right, what else did I say? I then said that the measure of angle 3 and 4 add up to 180 degrees. And that is the definition of same side interior angles. Once again, being a little bit lazy with my wording because I don't have a whole lot of space to deal with. If your teacher lets you be lazy, be lazy. If they don't, don't. But again, I'm being lazy here because space is limited for me. I'm not the best drawer. Good thing I'm not a dresser, am I right? 4. 4, I was able to say that the measure of angle 2 is equal to the measure of angle 3, and that's the definition of vertical angles. Don't know why I didn't just do those quote thingies again. Too late. Too late. Where am I now? I now know that since 2 and 3 are the same, I can rewrite line 3 and make this the measure of angle 2 plus the measure of angle 4 equals 180. And that was using substitution. So substitution, property of equality. So I'll just say substitution prop. Okay. Going back to red. Since 2 plus 4 equals 180 and 1 plus 4 equals 180, then the measure of angle 1 plus the measure of angle 4 equals the measure of angle 2 plus the measure of angle 4. And I could use substitution. I can use transitive property. I like transitive property, so let's use transitive property of equality. Last but not least, I could subtract the measure of angle 4 from both sides. I could subtract the measure of angle 4 from both sides, and that tells me that angle 1 is equal to the measure of angle 2, and that's the substitution property of equality. Subtraction property of equality. All this got me to that point where now 2 equals 1, 2 and 1 correspond, 2 and 1 are equal, which means A and B are parallel. So last but not least, I can't use green because it'll blend with the green down there. So let's go back to black. I could say that A is parallel to B, and that's because corresponding angles are congruent. Corresponding angles are congruent. All right, so this falls under the category of proving lines are parallel. Usually you have geometry books with sections dedicated to proving lines parallel. And when you're trying to prove lines parallel, you look at the 6 options that I gave you at the beginning of this problem and try to make one of those things happen. I did by showing that 1 and 2 are congruent, therefore A and B are parallel. And I'm done.